We are awesome. We are going to be going over 4 questions here. We're asked which of the following is not a correct partial derivative of the 4-variable function. And the 4-variable function is given to us right here, and we have to take the derivative, or the, integral with respect to dw, dx, dz, and then at the end we'll do dy. So first, to start this off, all of these underneath here, we're going to multiply everything by it so that we can get it to the other side. Once we're able to do that, we can take the integral of both sides. So this is not going to have a dw underneath it, it's going to be over here. And if we do that, you can see that everything is going to be a constant out front except for this guy. So if we were to rewrite this, it's going to be x to the 9th. We'll have our ln for y, and then e3z. And then here, if we take the integral of negative sine 5w, or we'll just say sine, taking the integral of sine is going to give us a negative cosine. So right here, we're going to have a negative cosine, and then 5w. We also have to, go about with what's inside. And inside of here, if you take the integral with 5w inside, we're going to have this 5 on the bottom. So it's going to be like this. And we also have to multiply it by a 5. Now from here, our 5s are going to cancel out. This is going to become a plus, and we can see it looks just like how we have it up top, which will be right here. So since it's like that, this is a correct partial derivative of the 4-variable function. Now let's look at the next one, b. Same thing, multiply both sides by dx, and then we're going to integrate. So everything is a constant except for our x. So that means all of this is going to be the same. Taking the integral of 9x of 8 is going to be 9x9 over 9. Our 9s are going to cancel out. So we just have x to the 9th times everything else. And from that, we can see that this is also correct partial derivative. Now we have 2 more to do, and I'm going to do c last because it's not the correct answer. It's good to do all the simpler ones first. That way, if you have a question like this, you can rule it out. So let's take the integral of this, dy. We can cancel out our 4's from here, and taking the integral of dy, remember everything else is just a constant, so we don't have to worry about any of this. We're essentially really just taking the integral of 1 over y, and that's just going to give us an ln of y, right? And when we multiply that in, oh, don't forget though, we should have, well actually, I think this might be a little bit of an error here because it should have a 4y, because if you look at our problem here, we have 4y here. Let's get rid of this 4 right here. So we should only have 1 4. My bad. So for example purposes, let's just say that we had a 4 here. It's not being multiplied by anything else. And so we have if we have a 4y in the denominator like this, we're going to get an ln of 4y. And so if we multiply this by everything up top here, we are going to get what we have up here. And so this is going to be correct also. So that means this is incorrect. How do we go about testing it though? The same way we did the other one. So integral both sides, multiply everything by dz. And from here, we know that all of this is constant. This is a constant. So really we're taking the integral of a z, e, 3z minus 1 dz. And from here, something like this, you're going to want to do like partial integrations. I think that's what it's called, where you essentially have your u, v, and then du, dv, and then it's like u times v minus the integral of v du, and you're just going to solve for this. But since this is like a multiple choice question, we're not going to do that here. You would see that you would not get a correct partial derivative. So that's how you could kind of rule that out, and that's how we would look at this problem.